Hello students, welcome back. So like I said, we are going to be doing a new topic now. Today's discussion will be on continuity and differentiability and applications of derivatives. It's a very long session because we know calculus is one of the most difficult topic for most of you, and we will be discussing one of the most important chapters in calculus today. Applications of derivatives. You know the importance of that chapter, right? So please, if you haven't shared this link with your friends, do it immediately and let them also get used of all those topics which may come for the examination. Applications of derivatives and continuity and differentiability. Okay, so I'm going straight away to the questions. We will go very slowly right today. So it's a longer session, so we will go step by step into the topics. I'm starting with applications of derivatives because right now all of you are fresh. So I want to use that to make use of getting marks in AOD. Case study, yes, very important. And 2 case studies according to sample papers, maybe not in the actual examination, but 2 case studies according to sample paper coming from AOD. And 1 mark questions also expected. So we do not want to lose those marks. So straight away to the questions. The first question in applications of derivatives is based on the topic of rate of change of quantities. And I do expect a case study to come from that. I've included 2 questions which could be analyzed in the way of a case study for applications of derivatives, rate of change of quantities. So straight away to the first question, my dears. The volume of a cube is increasing at the rate of 9 cubic centimeters per second. It's a volume of a cube. So all of you are supposed to know how a cube is calculating its volume. Volume of a cube is x cube. X represents the side of the cube. So we know V equals x cube and the volume is changing at the rate. So changing means the derivative of the volume is 3x squared. I am differentiating with respect to time t because the volume increases with respect to seconds. So dV by dt is 3x squared. Keep in mind, when you're differentiating a function in terms of x, okay, but with respect to time t, the derivative of x cube, you take it in the normal way, 3x squared, but don't forget to multiply dx by dt. It's a trick you can remember. I am differentiating x, so do it as you do normally, but always multiply with dx by dt. So we know the volume is increasing at 9, so dv by dt is 9, and we know that the side or the edge of the cube is 10 centimeters, so 3 into 10 centimeters squared is multiplied with dx by dt. So 3 and 9, it's 3 over here, so I can say the change in the edge of the cube is 3 by 100 centimeters per second. Now what is the question about? How fast surface area increases? What is the formula for surface area of a cube? Surface area of a cube is 6x squared. 6 squares make the surface of a cube, 6x squared. So what is the change in its surface area? Derivative of x squared, yes, again 2x, but don't forget change is with respect to time t, so multiply dx by dt. This happens in questions involving a variable which is differentiated with respect to another variable. X squared is differentiated with respect to another variable t. That's why this multiplication happens. So that is 6 into 2 into 10 into dx by dt is 3 by 100. Simplify it. 0, 0, 2 and 5. It's 18 by 5 centimeter squared per second. So how fast is the surface area increasing? 18 by 5 centimeter squared per second. You can leave it in fractions. You need not write in decimals. It's better you can leave it in fractions because subjective question. Don't waste your time finding decimal values. So, question very clear. I have given the change in the volume. I measure the change in the edge of the cube. Using that change, I measure the change in the surface area of the cube. Very simple question. Second question. The particle moves along the curve 6y equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing. All of you look, y coordinate changes. So please, you remember, changes means dy by dt equal to 8 times as fast as the x coordinate. So the change in y coordinate, why did I do it with respect to time t? Because they mentioned that the change is 8 times faster than. Speed is always measured with respect to time. Change in position with respect to time. So know it, dy by dt is 8 times dx by dt. Now keep that relationship in mind. Do the derivative here. Differentiate with respect to time t. What happens if you differentiate 6y? What's the derivative of y with respect to time t? dy by dt equal to derivative of x raised to 3, 3x squared, and don't forget dx by dt. Why? Because we're changing with respect to time. And what's the derivative of a constant? Obviously that is 0. Now I have dy by dt as 8 times dx by dt. 8 times dx by dt equal to 3x squared dx by dt. Can I take out dx by dt on both sides? I get the answer as x squared is equal to 16 and x is positive 4 or x is negative 4. So I got x squared equal to 16 and the values of x is 4 and minus 4. 4 and minus 4. Use those values in this equation to get the value of y. If x equal to positive 4, 6y is equal to 4 cube plus 2. 6y, 4 cube 64 plus 2 66. Y is equal to 11. So the first point where y changes 8 times faster than x is 4, 11. Now if x is equal to negative 4, 6y is equal to negative 4 cubed plus 2. 6y is equal to minus 64 plus 2. 6y is equal to minus 62. Y is equal to minus 31 by 3. Minus 31 by 3. So the second point where this change happens is minus 4 by comma minus 31 by 3. Okay, study the question. A very good question to be asked. Good, Vigneshwaran. Correct answers. So the change in y is 8 times faster than the change in x. 8 times faster than the change in x. Okay, good. I think everybody is clear with it. And why I differentiated with respect to time t. Why I differentiate with respect to time t. Question 3, a type of question which can come for case study, 4 marks. Okay, the question is about sand pouring from a pipe at the rate of 12 centimeter cube per second. This is the pipe from which sand is falling at the rate of 12 centimeter cube per second. Okay, now the falling sand forms a cone. If you want, you can test it. take some sand in your hand, just simply drop it down. The falling sand on the floor takes the shape of a cone. Okay, fine. So when the sand keeps falling, the volume of the cone keeps changing. So can I say from that the volume of the cone changes at the rate of 12 centimeter cube per second. The volume of the cone changes in the rate of 12 centimeter cube per second. Yes, I started getting answers already from students. Okay, let me see if that's the correct answer. Fine. And they said that, read this part of the question, it's very important. A very important information is going to come. It says that height of the cone is always 1/6 of the radius of the base. So we know this is the height, and here the radius is over here, and they're saying the height, the diagram is not the perfect, but height is 1/6 the radius. Why is it given like that? Because whenever we are differentiating a function in AOD, here you are differentiating the volume of the cone, you are supposed to have only one unknown variable in the expression. Here we have radius and height, not allowed. Here we have radius and height, not allowed. You're supposed to have maximum one variable. Keep this in mind for every question of AOD. You cannot have two variables simultaneously for differentiating in AOD questions. Okay, so I have to make a substitution. Let's see what to substitute. Here they are interested about the height, so do not substitute height, substitute the radius. So from this expression, can I say that radius is 6 times height? So my volume can be 1/3 pi 6h squared is 36h squared into h. Now my expression is, all of you please simplify, you're going to get a volume expression only in terms of a single variable, that is volume is equal to 12 pi h cubed. The volume is 12 pi h cubed. Now let's measure the change. Therefore, what is the change in volume? dV by dt. 12 pi is a constant. Derivative of h cube is 3h squared into dh by dt. And we have dV by dt, which is 12. The change in the volume is 12, equal to 12 pi into 3 into h squared is 16 into dh by dt. Solve it, you will get the expression for dh by dt. You can see that 12 and 12 cancels, and dh by dt, the change in the height is 1/48 pi. This answer was already given by Faris. No, not Faris, I'm sorry. Sarim and Vigneshwaran. Okay, they both gave this answer already. The change in the height is 1/48 pi centimeter per second. So how fast is the height increasing? 1/48 pi. Don't substitute pi. They are not interested in those kind of substitutions. Subjective questions, leave it like that. Okay, fine. 1/48 pi centimeter per second. Got it? Okay, fine. Good question, like a case study based question. Please keep in mind one very important thing. When you're trying to change the measure of a quantity in AOD chapter, the expression can have only one unknown variable. Only one unknown variable. Question 4. Same type of question, but this time you are not making a cone. The cone already exists in the shape of a conical vessel which is inverted. Inverted conical vessel. Okay, where the vertex is lowermost, its semi-vertical angle is tan inverse 0.5. What is meant by the semi-vertical angle? We know this is the radius of the cone, height of the cone. This is called the semi-vertical angle. Okay, let's be more familiar with it. Let's call it as theta. Semi-vertical angle is theta. So they say here the semi-vertical angle theta is tan inverse 0.5. Yes, that implies inverse trigonometry tan theta equal to 0.5. According to 10 standard trigonometry and the relation in triangles, tan theta is opposite side by adjacent side. Opposite side R, adjacent side H equal to 0.5 is 1 by 2. That implies R equal to H by 2. Did I get a relationship between R and H? In the previous question also, we used a relationship between R and H here, over here. Why was that? Because I want my expression in terms of a single variable, not two variables. So here, what's my volume going to be then? Therefore, volume again 1 by 3 pi R squared H. Substitute R, my dears. R is going to be H squared by 4 into H. That is volume is pi by 12 H cubed. I got volume in terms of a single variable H. Now I'm going to measure the change in the level of the water. That's height. Change in the level of the water. Therefore, the volume change is given by pi by 12. What's the derivative of H cube? 3H squared. And like I said, change with respect to time. So you have to multiply dH by dt. Right answer coming from Nitin already. Now substitute dV by dt. The volume of water in the vessel changes at what rate? Water is poured into it at a constant rate of 5 cubic meter per hour. So we have the change in the volume equal to 5, and at that particular instant the level of the water or the height of the water in the tank is 4. Substitute this. 5 is equal to pi by 12 into 3 into H squared into dH by dt. Can I take out this 12 with 3 and 4? So I have 5 by 4 left out. So what's the change in the height? What is the change in the level of water? It is 5 by 4 centimeters per second. 5 by 4 centimeters per second. Yes? Got it? Oh, we do have a pi. Forgot about the pi. So 5 by 4 pi. 5 by 4 pi. Okay? So right answers coming from Adil, Dhruvil. Yes, very good. So keep doing. It's not a difficult question. Rate of change is something which is easy for you. And why I'm asking you to practice this is because sample paper says about 2 case studies. So one case study we all can anticipate is maxima and minima. But the second case study is always confusing. It could be from rate of change. So I want my students to practice this idea of changing the volume of a substance, surface area of a substance. But please go back to your 10th standard solid geometry. Revise all the formulas with respect to volume, surface area of the solids. Please, if you do not know, please at least go online and refer to the formulas before going for your board exam. You should not be worried about this. Okay? Now, so 5 by 4 pi and the unit was meters per hour. Meters per hour. Okay? Fine. Next, find the angle theta. Very interesting question for 2 marks. Because we do have a question for 2 marks from this differentiation chapters. It be case study, sorry, it could be from AOD or even from continuity and differentiability. So this is a 2-mark question which is very important. Find the angle theta which is between 0 and pi by 2, that is in the first quadrant, which increases, theta increases twice as fast as, again the word faster, speed, change with respect to time. So therefore it said that the change in what, my dear students? The change in the angle theta is, the change in the angle theta is 2 times faster than the change in its sine. Sine stands for sine theta. This is the expression. This is the expression, all of you. D by dt of theta is equal to 2 times d by dt of sine theta. So there is nothing difficult about saying that d by dt of theta is simply d theta by dt. Yes, is equal to derivative of sine theta is cos theta, but the change is measured with respect to time. So definitely d theta by dt. D theta by dt. Can I take out d theta by dt on both sides of the equation? Okay. So now after that, I will get cos theta equal to 1. There was a 1 here after cancelling, by 2. If cos theta is equal to 1 by 2, theta please. Very good, Dhruvil. Very good, Prapti. Right answer. It is pi by 3. Now I want my students to study this question very well, and this kind of a question could be very crucial for you in the exam. Some of you might not even know how to write that relationship, and some of you will forget about d theta by dt. It has happened for many of you because this kind of a situation arises in derivatives of parametric forms, where your y and x are in terms of a third variable called theta or t, and when you go for the second derivative of that expression, you forget to take this derivative which is with respect to x. So please, my dear students, keep in mind, whenever you're differentiating a function which is in terms of another variable, but differentiation happens with respect to another variable, this kind of a derivative form comes at the end of the derivative. Please don't forget it. Please be careful when you're differentiating variables with more than 2 variables in the same equation. Okay? Question number 6. So from rate of change, that much is enough. It gives you more than enough idea on how it works. Because we are not expecting a lot of small 2-mark questions from AOD. We are only expecting case studies and 1-mark questions. Okay, so please, we have done 1-mark questions already, MCQs. You can just go back and revise. But these kind of questions, 3 marks, very important. First question for 3 marks. Show that the function is strictly increasing on R. What is the meaning that a function is strictly increasing in R? F of x is strictly increasing in real numbers implies f dash of x is strictly greater than 0. It's a very good condition to study for MCQ also. What is the condition to remember if f of x is strictly increasing in R? F dash of x is strictly greater than 0. Okay, f dash of x strictly greater than 0 for all x that belongs to real numbers. Let me see. What is the meaning of this? Okay, therefore, what is f dash of x? Derivative, please. 3x squared minus 6x plus 4. This is f dash of x. How do I show that this particular function is strictly greater than 0? One way is, a function is strictly increasing or strictly decreasing if there are no critical points. A function is strictly increasing or strictly decreasing if there are no critical points in the function. A critical point happens because a function goes like this. Somewhere it turns and comes down. This particular point with respect to x-axis is called the critical point of that function, where the nature of the graph changes from increasing to decreasing or from decreasing to increasing. It's called a critical point. So we just have to check whether this function has a critical point or not. If it does not have, then it is either strictly increasing or strictly decreasing. Okay? So here, let 3x squared minus 6x plus 4 equal to 0. If dash of x equal to 0, then x is a critical point. Yes or no? We all know that. How do you find a critical point for a function? Find the first derivative, equate it to 0. The value of x which equates that first derivative to 0 is called its critical point. Here, let's see if we have a critical point like that. So I just set this quadratic equation equal to 0. And I'm going to tell you why there is no critical point. Now, b squared minus 4ac equals minus 6 squared minus 4ac. 36 minus 48, which is negative 12. When I have a discriminant for a quadratic equation which is negative, that implies x has no real roots. I cannot find a real number which is a root, means which makes it 0. That is, f dash of x can never become 0 for any x which is a real number. So this is the first conclusion, that f dash of x is never 0. So from that, what can I conclude? F of x is either strictly increasing or strictly decreasing. It's a 3-mark question, so we have to prove it like this. First one, I showed that the first derivative is a quadratic equation. Then I showed that for that quadratic equation there is no real number which is a 0. That is, I cannot find a critical point for it. So if there is no critical point for it, f of x is either increasing or decreasing. Got it? But I have to show it is strictly increasing. How can I show it's strictly increasing? I have to prove that the first derivative is always positive. Simple idea. It's either going up or going down. Just take any number. Just take any number and substitute in f dash of x. You will get 3 into 0 squared minus 6 into 0 plus 4, which is 4 greater than 0. I proved that the first derivative is greater than 0, so it's strictly increasing. Now question might come, sir, you could have done this in the first place. Why do you need to do all this to say that it's positive and greater than 0, hence it's increasing? You could have done this in the first place. I cannot, because I'm not sure whether this function is increasing or decreasing without a critical point. Got it? 0 could have been a point where it was increasing, but we do not know that if there is a critical point before or after 0. So I ensured in this entire set of real numbers there is no critical point. So it has to be either going up continuously or going down continuously. And I chose to prove it's going up by putting any value as a real number here, and I got that f dash is positive, so my function should be strictly increasing in R. This is one easy way to prove that the function is strictly increasing in R. Therefore, f of x is strictly increasing in R. This is a technique we use for other questions, right? Substituting a point, proving that in that particular interval that function is positive, hence it is strictly increasing in that particular interval. Here the interval is all real numbers because there is no critical point to break the interval. All real numbers. I believe everybody is clear. Okay? Got it. Question 7. This is what I've been saying. Find the intervals where it is strictly increasing and strictly decreasing. Question is very clear. The function is given. So straight away f dash of x. 12x squared minus 12x minus 72. Take 12 common out. X squared minus x minus 6. Factorize the quadratic equation. X minus 3 into x plus 2. Factorized form of the quadratic equation. Now I'm trying to find the critical points. Let f dash of x equal to 0. That means 12 into x minus 3 into x plus 2 equal to 0. From this clearly x equal to 3 and x equal to minus 2 are critical points. Yes? X equal to 3 and x equal to minus 2 are your critical points. Now, most basic question in 3 marks, increasing, decreasing. A function given, a polynomial function given, finding the critical points and breaking the number line at minus 2 and 3. So I have 3 intervals to check its nature. Start with the first interval, all of you. Start with the first interval, minus infinity up to minus 2. Second interval, minus 2 up to 3. Third interval, 3 to plus infinity. Then f dash of x equal to 12 into x minus 3 into x plus 2. Take any value from the first interval, preferably minus 3. So I tried f dash of minus 3 and I got what answer? Positive or negative? 12 minus 3 is negative. No need to find the value actually. Minus 3 is minus 6, which is negative. Minus 3 plus 2 is again negative. So product of negative and negative is positive. Nobody is asking you to find whether the value is there or not. No, nobody is interested. They are interested to check whether it is positive or negative. If it's positive, I can say that in this interval it is strictly increasing. Strictly increasing. That's the nature of the interval. That's the nature of the interval. It's strictly increasing. Same idea, please continue for the other intervals. I'm trying with f dash of 0 here. 12 into 0 minus 3 is negative. 0 plus 2 is positive. So my answer is the product, which is negative. So it's strictly decreasing. Then try the next one, f dash of 4. 12 into 4 minus 3, positive. 4 plus 2, positive. Final answer, positive. So positive means strictly increasing. Positive means greater than 0. Negative means less than 0. So when do I say a function is strictly increasing? If the first derivative is greater than 0. Strictly decreasing, first derivative is less than 0. Now final answer. Final answer. Question number 1. Strictly increasing. Which interval is strictly increasing? The first and the last. So write it like this. Minus infinity up to minus 2 union 3 to infinity. Minus infinity up to minus 2 union 3 to infinity. Second one, strictly decreasing in the middle interval -2 up to 3. Strictly decreasing in -2 up to 3. Got it? So please, you have to take it and write it like this if you want to get full marks. Two intervals of increasing, so write it as a union of those two intervals. And there's only one interval of decreasing, so write it separately. Okay? Easy question, basic question for 3 marks. A polynomial, you can keep practicing. A cubic polynomial is what is expected for 3 marks. Okay, a cubic polynomial is what is expected for 3 marks. Question 8, trigonometry, 3 marks. Read it. F of x equal to sine 3x. So what is f dash of x? F dash of x is derivative of sine 3x, which is cos 3x into the derivative of 3x. Chain rule, derivative of 3x. F dash of x is equal to 3 cos 3x. F dash of x equal to 3 cos 3x. Now I'm trying to find the critical points. Here, f dash of x equal to 0 implies 3 cos 3x equal to 0 implies cos 3x equal to 0. I have to find out the angles or values of x which makes cos 3x 0. Cos 3x 0, normally cos x becomes 0 in 90. But here you have a confusion in the question. The question says x belongs to 0 to pi by 2. Here x is an angle which falls between 0 and pi by 2. But my angle is no longer x, it's 3x. So I have to think about angles between 0 and 3 pi by 2. Angles between 0 and 3 pi by 2, which makes cos of that 0. Cos of that 0. Okay, so 3x talks about all the angles from 0 to 3 pi by 2. You have to think about all the angles from 0 to 3 pi by 2. Can anyone start telling me the first angle which makes it 0? The first angle which makes it 0. Okay? No, you cannot say like that, Dhruval. X is between 0 and pi by 2, then how can you change it as 0 and pi by 6? Okay? So let's say 3x equal to pi by 2. Yes? If 3x is pi by 2, we know cos 90 is 0. Yes? So 3x is equal to pi by 2 implies x is equal to pi by 6. X is equal to pi by 6. After pi by 2, is there any angle up to 3 pi by 2 which makes it 0? Up to 3 pi by 2. There is nothing. You cannot take 0 and pi by 2 as the critical points. Please, according to the definition of increasing decreasing functions, the interval limits cannot be considered as critical points. Only the value which falls within the interval. So there's only one value for x here, which is pi by 6. Got it? The only value of x is what? Pi by 6. So you're going to tell me the interval where it is increasing and the interval where it is decreasing. Okay, so here let's break our interval which lies between 0 and pi by 2, and pi by 6 is here. Okay, you're talking about the interval from 0 to pi by 2, and pi by 6 is the critical point. Once again, keep in mind, why did I say 3x can be pi by 2? Some of you will be confused because you know that it's from 0 to pi by 2. Sir, we have been taught that the interval limits cannot be considered as critical points. I am talking about 3x, not about x. 3x is pi by 2, because if x is from 0 to pi by 2, 3x can go up to 3 pi by 2. So I can consider any angle from 0 to 3 pi by 2, which makes cos 3x 0. And there's only one angle, that's pi by 2. Okay, now let's think about the intervals. First interval 0 to pi by 6. Second interval pi by 6 to pi by 2. What is your f dash? Your f dash is 3 cos 3x. 3 cos 3x. Tell me any angle between 0 and 30 or 0 and pi by 6. What comes to my mind is pi by 12. If you put pi by 12, your answer is 3 cos 3 into pi by 12, which is pi by 4, and which is definitely positive because cos pi by 4 is a positive value. Now if you think about any angle over here, I can say pi by 4, which is 45 degrees greater than 30. 3 cos pi by 4 is 3 pi by 4, which, my dear students, I'm not concerned about even calculating. It's negative because 3 pi by 4 falls in the second quadrant. Pi by 4 is 45. Then 2 times pi by 4 is 90. Then 3 times pi by 4 is definitely 135 degrees, which falls in the second quadrant, where cos is negative. Cos is negative. I'm not concerned about the value. Please don't waste your time calculating values here. Okay, so what's the nature? Increasing or strictly increasing and strictly decreasing. So what is your answer? Final answer, my dear students. You can write here strictly increasing in 0 to pi by 6. Strictly decreasing in pi by 6 to pi by 2. Strictly increasing in 0 to pi by 6. Strictly decreasing in pi by 6 to pi by 2. Yeah, you can write straight away positive, negative, trivial in exam also, because they are also not interested in the final value. They want to only understand the nature of each interval. Okay? Nobody asks you the value of f dash. They want to know if it's greater than 0 or less than 0. You can just show positive, negative here. Okay? I think everybody is clear with question 8. Yes? Question 9. Sin x plus cos x is a standard question from your textbook only. F dash of x is cos x minus sin x. F dash of x is cos x minus sin x. Let the first derivative equal to 0. Let the first derivative equal to 0. That implies cos x minus sin x equal to 0. That is cos x equal to sin x. That implies tan x, sin by cos, tan x is 1. And x, my dears, is between 0 to 2 pi. The 4 quadrants are involved here. All the 4 quadrants are involved. From 0 up to 2 pi. I have to think about the angles of tan, which makes 1 for tan x. Okay? Definitely the first one without a doubt is 45. Tan 45 is 1. But I will not look at the second quadrant. Why? Because tan is negative here. I want positive answer. My dears, I want a positive answer. So I'm not at all interested in the second quadrant. And again, I'm not interested in the fourth quadrant also, because tan is negative. So I am less interested in the second quadrant and fourth quadrant, because those two quadrants make tan x negative, but I want a positive answer. So the only quadrant that we can select is the third one, the second quadrant, where it's positive. Tan x is positive in the first quadrant and the third quadrant. But when it comes to third quadrant, we are supposed to know this. The angle will be pi plus alpha. What is the allied angle of alpha in the first quadrant to the third quadrant? Pi plus alpha. So that implies x is pi by 4 or x is pi plus pi by 4, which is 5 pi by 4. Most of the students will miss the second critical point. Most of the students will be very careless. You will miss the second critical point. That's why I said with a lot of explanation why I had to consider the third quadrant as well, where tan x can be positive 1. Where tan x can be positive 1. Yes, I got answers from Vigneshwaran, Prapti, Dhruvil. 3 of you gave the answers. Good. So please learn this, my dear students. Those who do not know it, please learn it. Now this can break into 3. 0 to 2 pi. This is pi by 4. This is 5 pi by 4. I got now 3 intervals to test. Okay, the first interval 0 to pi by 4, the second interval pi by 4 to 5 pi by 4, and the third interval 5 pi by 4 to 2 pi. Okay, intervals ready? Write your first derivative. F dash of x is cos x minus sin x. Cos x minus sin x. You just take any value from this. 30 degrees. Cos 30 minus sin 30. Cos 30 is root 3 by 2. Sin 30 is 1 by 2. Cos 30 minus sin 30. Cos 30 root 3 by 2. Sin 30 1 by 2. Definitely answer is positive. Any angle from pi by 4 up to 5 pi by 4. The best angle I can think about is over here. Pi by 2. Cos pi by 2 0. Sin pi by 2 1. Negative answer. Then from 5 pi by 4 to 2 pi, the best angle I can think about is 270 or 3 pi by 2. Cos 3 pi by 2. Cos pi by 2 is 0, then definitely cos of 3 pi by 2 also is 0. Minus sin pi by 2 is 1. Sin 3 pi by 2 is minus 1. So the answer is positive. So I got the nature now. First interval strictly increasing. Second interval strictly decreasing. Third interval strictly increasing. 3 intervals fixed. We can write the final answer now. Not wasting time on writing it again. So where is it strictly increasing? It's strictly increasing from 0 to pi by 4 and 5 pi by 4 to 2 pi. Strictly increasing in 0 to pi by 4 and 5 pi by 4 to 2 pi, and strictly decreasing in pi by 4 up to 5 pi by 4. Clear, all of you? Very easy for question to do like this. If anybody is having doubts, you may ask. I've done 2 questions based on trigonometry. One is sine 3x, the other one is sine x plus cos x. Okay? I hope everybody is clear with this idea. Question number 9. Moving to question number 10. Show that this function is strictly increasing for all values of x greater than -1 throughout its domain. Domain means the values of x, and here the values of x are all greater than -1. So I have to prove that for every value of x greater than -1, this particular function is strictly increasing. Strictly increasing means what? Oh, it's not strictly increasing, I'm sorry. Show that y is increasing. There is a slight difference between strictly increasing and increasing. There is a slight difference. Remember, strictly increasing means the derivative, the first derivative should be strictly greater than 0. This is not strictly increasing, so it need not be strictly greater than 0. It can be greater than or equal to 0. Right answer, Dhruval. If you want to prove that a particular function is increasing, not strictly increasing, you just have to show that the first derivative is greater than or equal to 0. So let's go after derivative now. dy by dx. What's the derivative of log 1 plus x? 1 by 1 plus x. Derivative of log 1 plus x, 1 by 1 plus x. Now the derivative of 2x by 2 plus x, I'm going to use quotient rule. So the denominator is going to be 2 plus x squared. Numerator is u dash 2 multiplied with v 2 plus x minus u 2x multiplied with v dash 1. 2 into 2 plus x minus 2x into 1. So the answer is 1 by 1 plus x minus 4 plus 2x minus 2x by 2 plus x squared. Normal derivative. I haven't done anything new here. I just simply took the derivative of the function. Now the remaining steps are a bit very important, because you have to show that it's greater than or equal to 0. You cannot simply show it just taking the LCM here. 1 into 2 plus x squared minus 4 into 1 plus x whole divided by 1 plus x into 2 plus x squared. LCM please. LCM of the expression in the previous step. Cross multiply and LCM. Simplify it. 2 plus x squared, 4 plus 4x plus x squared. Multiply minus 4 minus 4x divided by 1 plus x, 2 plus x squared. Simplified 4 minus 4 plus 4x minus 4x. Your final answer is x squared by 1 plus x into 2 plus x squared. Okay, got it all of you? 1 plus x into 2 plus x squared. This is enough. Now I'll show you how I can say the first derivative is strictly or no, is greater than or equal to 0. Here x squared is definitely greater than or equal to 0, whatever be the value of x. Forget about being greater than minus 1. X squared is the square of a real number, which is definitely a positive number, but it can be 0 also if I put x equal to 0. So x squared is always greater than or equal to 0. Now let's come for 2 plus x squared. Again, 2 plus x squared is strictly greater than 0 here. Why strictly greater than 0? Why can't it be 0? If it has to become 0, I have to put x as minus 2. If I put x minus 2, 2 minus 2 will make it 0. But for every other number, if I put in that, I will always get a positive answer because it's being squared. But here I cannot put minus 2. Simple reason. What is the simple reason? X is not minus 2. The simple reason, x is greater than minus 1. They said this in the question already, that the value of x should be greater than minus 1. Minus 2 is not greater than minus 1. So I cannot put minus 2. So 2 plus x squared in the denominator cannot become 0. It should be positive. Now the last term is the confusing term for many of you, 1 plus x, and I confidently will say that 1 plus x is also strictly greater than 0. Two ways you can say it. Because they said x is greater than minus 1, you keep substituting values of x greater than minus 1, you will definitely get positive 0. Greater than 0, greater than 0. Greater than minus 1, put minus 0.5, you get greater than 0. Minus 0.9 also greater than 0. This is one way of thinking. The other way is x greater than minus 1 implies, bring the minus 1 to the left side, 1 plus x is greater than 0. Easy way is this. X is greater than minus 1, so 1 plus x is greater than 0. So this is also greater than 0. Now look at my expression. This is the explanation for your answer. This is the explanation for your answer, my dears. Now you've seen that this part is greater than or equal to 0. This part is strictly greater than 0. And this part is also strictly greater than 0. Greater than 0 positive, greater than 0 positive, greater than or equal to 0 positive. Positive by positive is always positive. So I know that my answer is greater than 0, but I can put also equal to 0 because numerator can be 0 also. Numerator can be 0 also. So I can get the answer greater than or equal to 0. Therefore, dy by dx is greater than or equal to 0 implies y is increasing throughout its domain. Proof done. Y is increasing throughout its domain. I believe everybody is clear with the answer. Yes? Clear? Good. Next question, please. Prove that this is also an increasing function. Same way. Is derivative with respect to theta. Quotient rule. 2 plus cos theta squared. U dash. 4 cos theta into 2 plus cos theta minus 4 sin theta into minus sin theta. Okay? Minus derivative of theta is 1. For the first term, quotient rule. Open the numerator. 8 cos theta plus 4 cos squared theta plus 4 sin squared theta divided by 2 plus cos theta squared minus 1. all of you please look at this term, 4 cos squared theta plus 4 sin squared theta. You take 4 common out, it's cos squared plus sin squared, which is 1. So because of that simple reason, I can write this as 8 cos theta plus 4 into 1. And I'm taking LCM also with this. I'm taking the LCM also with this. This is going to be minus 2 plus cos theta squared by 2 plus cos theta squared. LCM also I'm taking. Simplify it further. 8 cos theta plus 4. Open the bracket. 4 minus 4 cos theta minus cos squared theta divided by 2 plus cos theta squared. Cancel the terms, 4 and minus 4. 8 cos theta minus 4 cos theta. 8 cos theta minus 4 cos theta is 4 cos theta minus cos squared theta divided by 2 plus cos theta squared. From the numerator, please take cos theta common. You will get cos theta into 4 minus cos theta by 2 plus cos theta squared. Leave it here. This is the best I can simplify this expression. I took cos theta common from the numerator, cos theta into 4 minus cos theta by 2 plus cos theta squared. Now I want all of you to look at every term. Cos theta, I would say, is greater than or equal to 0. Cos theta is greater than or equal to 0 in the first quadrant, 0 to pi by 2. Why 0? Because cos pi by 2 is 0. Pi by 2 is included in the domain. Pi by 2 is included in the domain, so it can become 0. But this term, my dears, is strictly greater than 0. Simply because cos theta, the biggest value is 1 and the smallest value is minus 1. Cos theta, the biggest value is 1, smallest value is 1, minus 1. So 4 minus 1 is 3 and the smallest value is minus 1. 4 plus 1 is 5. You can never make it 0 and it will never become negative also. The biggest is 1 and that itself is only 3. It is not going below 3. So you will always get a greater number than 0. And 2 plus cos theta, same explanation, is going to be strictly greater than 0. If it has to become 0, this should become minus 2. Impossible. Cos theta cannot become minus 2. Cos theta is between, reason all of you? Reason because cos theta is in minus 1 to 1. And here I don't have to even think about the negative sign, because in the first quadrant, cos theta in 0 to pi by 2 is 0 to 1. It's always positive, and these positive numbers is not going to make any of those terms 0 other than cos theta. So this dy by d theta can be concluded as greater than or equal to 0, hence y is increasing. Hence y is increasing in 0 to pi by 2. Y is increasing in 0 to pi by 2. Clear, my dears? Yes? Okay, next question please. Prove that the function is neither increasing nor decreasing. It's a 2-mark question. How do I prove that a particular function is neither increasing nor decreasing in its domain? To prove f of x is neither increasing nor decreasing in the domain, please remember the technique. Just prove that there is a critical point, in the domain. Do you remember the first question in increasing, decreasing, which I said that if there is no critical point, then it is either strictly increasing or strictly decreasing. No critical point. But if there is a critical point, it is neither strictly increasing nor strictly decreasing. Learn it, all of you. If there is no critical point, it is either strictly increasing or strictly decreasing. If there is a critical point, it is neither strictly increasing nor strictly decreasing. So let me find f dash of x equal to 2x minus 1. Let f dash of x equal to 0. 2x minus 1 equal to 0. X is equal to 1 by 2. And this 1 by 2 belongs to the domain minus 1 to 1. The domain is minus 1 to 1. So we have a critical point. So there exists a critical point in the domain. It's a 2-mark question. There exists a critical point in the domain. So if there exists a critical point in the domain, that implies f of x is neither strictly increasing nor strictly decreasing. Answer done. All of you clear with the answer? Yes? Got it? So once again, keep the technique in mind. How to prove it's neither increasing nor decreasing? Getting a critical point in the domain. How to prove it's either increasing or decreasing? Prove there is no critical point in the domain. And after proving there is no critical point, we can also confirm whether it is strictly increasing or strictly decreasing. Just take any value in that domain and put and check. If you get a positive first f dash, strictly increasing in the domain. If you get a negative f dash, strictly decreasing in the domain. Got it? Question 13. F of x is equal to sin x minus cos x. Find the local maxima and local minima, if any. Need not be there, but if there is, find it. So what is f dash of x here? It is cos x plus sin x. So f dash of x equal to 0 implies cos x plus sin x equal to 0. Cos x equal to minus sin x implies tan x equal to negative 1. I hope you remember doing a question with positive 1 before. So it's negative this time. Negative in the sense it should be in the second quadrant or in the fourth quadrant. Negative happens for tan x in the second quadrant and fourth quadrant. And we do know what is alpha. What is alpha, my dears? Alpha is pi by 4. Therefore, x is equal to pi minus pi by 4, or x is equal to 2 pi minus pi by 4. So x is equal to 3 pi by 4 or x is equal to 7 pi by 4. I got two critical points, but I don't know which one is maxima and which one is minima. And that is based on second derivative, right? How do you prove maxima, minima? After getting a critical point. For increasing, decreasing critical point will break the interval into 3 or 4 parts. Then you take each interval one by one and analyze its nature. But for maxima, minima, you don't need any intervals here. Just go for the second derivative, f double dash of x. The first derivative is here, second derivative cos x minus sin x, and derivative sin x is cos x. I got the second derivative with me, and I will check each critical point. And what is the condition for maxima, minima, all of you? If a critical point gives me a negative answer, then that critical point is a maxima, local maxima. Let's see. Minus sine 3 pi by 4 plus cos 3 pi by 4. Here there is no excuse. We have to find the value. Pi by 4 is 45. And giving an easy technique, pi by 4 represents 45. But we need to know which quadrant. 3 pi by 4 belongs to second quadrant. 3 pi by 4 we know belongs to which quadrant? Second quadrant. Where it's minus already for sine 1 by root 2. There is already a negative sign, but second quadrant sign is positive. So positive 1 by root 2. Now negative 1 by root 2 for cos, because in second quadrant cos is negative. So don't break your head too much on finding these. Okay? Got it? 3 pi by 4 is third quadrant, and just think what is the value of sine pi by 4, which is 1 by root 2. Just put 1 by root 2 and the correct sign for the quadrant. So the answer is minus 2 by root 2, which is less than 0, no doubt. So therefore x equal to 3 pi by 4 is a point of local maxima. So I got a point of local maxima, which is 3 pi by 4. Once again, how do I prove that a particular point is a local maxima? Just get the second derivative. If it's negative, it's a point of local maxima. Try the next one. F double dash of 7 pi by 4, which belongs to the fourth quadrant. So minus sine 7 pi by 4 plus cos 7 pi by 4. It's again pi by 4. Value is 1 by root 2. The only confusion is the sign. We know that in fourth quadrant sine is negative but cos is positive. So minus 1 by root 2 with minus is 1 by root 2. 1 by root 2 plus 1 by root 2, 2 by root 2. It's a positive answer. It's a positive answer. So x is equal to 7 pi by 4 is a point of local minima. X is equal to 7 pi by 4 is a point of local minima. Two values, my dears, maxima, minima. Just cross check all of you if the idea is very clear. Okay, we have two values, 3 pi by 4, 7 pi by 4. We analyze them as point of local maxima, local minima. Now we have to find the maximum and minimum value. For that we just substitute maxima in the function, get the maximum value. So maximum value equals f of 3 pi by 4, which is sine 3 pi by 4 1 by root 2 minus cos 3 pi by 4 minus 1 by root 2, which is 2 by root 2 equal to root 2. So my maximum value is root 2. Minimum value f of 7 pi by 4, you can substitute, you will get the answer negative root 2. Minus 2 by root 2, which is negative root 2. You can substitute and check. Fourth quadrant, sine is negative. So minus 1 by root 2, cos is positive, but there is already a minus. Minus 1 by root 2, it's minus 2 by root 2, which is minus root 2. Okay, so please, again, a very good question for 3 marks. Please try to study it, all of you. I just found out what's maxima minima. Okay, if they want to ask a question for 3 marks for maxima minima, it could be something like this. Just giving you a function, trying to find the critical points, and trying to make you state whether it's maxima or a minima. But this is one least expected question, because we have a case study being expected from maxima minima. But increasing, decreasing, you could expect a 3-mark question, or that could also be modified as a function for case study. So we just practicing questions which could be modified, conditions could be used for case study also. Okay, simple 2-mark question from maxima minima. Find the value of a if x equal to 1 is a point where you get maximum value. X equal to 1 gives maximum value, implies maxima or minima. It's always a critical point. Maximum or minimum, we do not care, but that value of x is always a critical point. So x equal to 1 is a critical point. X equal to 1 is a critical point. So if it's a critical point, that implies f dash of x equal to 0 if x equal to 1. So what is f dash of x, my dears? 4x cubed minus 124x plus a equal to 0 if x equal to 1. Substitute x equal to 1, 4 1 cubed, 124 1 plus a equal to 0. 4 minus 124 minus 120 plus a equal to 0. A is equal to 120. A very good expected question for 2 marks. We are expecting a question from this differentiation calculus for 2 marks. It could be increasing, decreasing. It could be from rate of change, or it could be from maxima minima, from AOD, or maybe normal differentiation also they can ask. We don't want to take a chance. Good question to be asked for 2 marks from maxima minima. Okay. 15. Find, this is again a second question which is very important for 2 marks. Find the maximum and minimum value, if any, for the following function. This is a function with modulus, and we do know that. Please refer my MCQ discussion on continuity and differentiability. Modulus functions are not differentiable. Modulus functions are not differentiable. If I say exactly, modulus functions are not differentiable for the value of x which makes it 0. Not all values of x. The values of x which makes the modulus function 0 is the point where modulus functions are not differentiable. Here, can you look at it and say that sine 4x is always a value between -1 and 1. The value of sine is always from -1 to 1. Yes? Prapti, good. Answers coming. So if I add 3 to it, -1 plus 3 is sine 4x plus 3. 1 plus 3. So 2 less than or equal to sine 4x plus 3 less than or equal to 4. Even if I apply modulus, no problem, because all values are positive. In case this was -2, modulus will neglect the negative side of the interval. I'll show an example that would be better. If by chance I got a function, if by chance I got the value of a function between -3 and 5. Then if I take the modulus of that function, this modulus neglects the negative side of it and starts from 0. Please keep in mind, if the range of a function has the negative side of the interval, if you apply modulus to it, it automatically neglects the negative side of it. Here, there is no negative side to neglect, so we know that the minimum value you can get for this modulus is 2, and the maximum value you can get for the modulus is 4. 2 and 4. Keep in mind, good question for 2 marks. Right answer, Prapti. Very good. So we got a minimum value of 2 and a maximum value of 4. Now, this is some questions which I tried to include in this discussion for just doing our case study based questions. Just for few of them. I'm not saying that this is very important, but just to give you an idea on how to approach a case study in AOD. Okay, we cannot do a lot of questions in AOD case study. Case study discussions have happened in classes a lot number of times, so I'm not going to discuss too much on these kind of things. So we're just going to be giving a basic idea on how to approach a case study based questions. Rectangular sheet with dimensions 45 by 24. 45 by 24 is to be made into a box without a top by cutting off square from each corner. Cut off square from each corner. And if you cut off a square from each corner, you can get a shape which looks like a positive sign. If you fold these flaps, you can see it has become a box which is open at the top. Now, the common mistake I've seen with many students is they do know that the square should be taken as x. Everybody knows that. But the mistake that they do in the exam is they forget to subtract both the x from the dimension. They subtract x but only 1. And many students do this mistake. So actual length of the sheet was 45, but after you cut off the square from both the corners, the length is now 45 minus 2x. It's a common mistake I've seen. I don't know why these students make this mistake again and again. They have clearly drawn the diagram, but they still take only 1x from the corner. Both corners. What's the breadth of the box? 24 minus 2x. And what is the height of this box? You're folding this flap, which makes the height or the wall of the box. And that wall is going to be having a square dimension, right? And that square dimension will give you a height also as x. If you cannot understand by heart. When a box is made by cutting of squares from its corner, the length is going to be the length of the sheet minus 2x. The width is going to be width of the sheet minus 2x. And the height is always x. Please, by heart it. Now I am interested about the volume of the box. Volume of the box is length into breadth into height, which is 45 minus 2x, 24 minus 2x multiplied with x. Okay, can you please multiply and open the bracket? 45 times 24, 45 times 24, all of you, it's going to be 180 and 90, which is 081080, minus 90x minus 48x plus 4x squared into x. Okay, multiply the x also inside and rearrange it correctly. 4x cubed. 90 and 48 is 138, so minus 138 x squared plus 1080x. This is the volume of the box. Now differentiate the volume of the box I've written the expression of the volume in terms of a single variable. From the beginning I have been saying, whatever you're trying to do in the AOD chapter, the function should be in terms of a single variable. I had three unknowns, length, breadth and height. I have converted into a single expression with a single variable of x. Now start derivative. dv by dx is 12x squared minus 276x plus 1080. Derivative done. Let's take dv by dx equal to 0. That is 12x squared minus 276x plus 1080 equal to 0. 12 is common. Take it out. It's x squared minus 23x plus 90 equal to 0. Factorize it. 12 into product 90, sum 23, x minus 18, x minus 5. That implies x is equal to 18 or x equal to 5. But we will reject 18. Normally for case study based questions or practical problems of maxima minima cannot have more than one critical point which is accepted. So there's only one critical point. Why is 18 rejected? If I put x is equal to 18 in breadth, 24 minus 36, negative breadth will come. Reject it, obviously. So x is equal to 5 is your answer. Okay, critical point done. Now I have to show that the volume of the box is maximum. Simple case, take the second derivative. Second derivative of the volume is 24x minus 276. Substitute 5, 24 into 5 minus 276. And that is 24 5s are 120 minus 276, which is a negative answer. So definitely volume is maximum. Volume is maximum. All of you please go through the idea of maxima minima, form an expression in terms of a single variable, find the derivative, get the critical point, show its maximum or minimum according to the question. Okay? Clear? I don't think this question is a very difficult question. I just put it so that there are certain students who are still struggling in this also. Okay, but very simple question. Keep in mind, the idea is what is required. Try to get an expression for the variable which you are trying to maximize or minimize in terms of a single variable. The relationship will be given in the question. You just have to use it wisely. Next question. A rectangle is inscribed in a semicircle of radius r. So I have a semicircle, okay, and the radius of the semicircle is r. And a rectangle is inscribed inside the semicircle like this, in such a way that one of its sides is along the diameter of the semicircle. Find the dimensions of the rectangle. So let me say that let the length of the rectangle is 2x and the width of the rectangle is y. I took it as 2x because I need to construct a triangle inside this. I need to construct this triangle over here. If I take it as x, the side of the triangle will become x by 2. And I do not prefer fractions in calculations. So that's why I took it as 2x. Let length equal to 2x, width equal to y. Okay, now I consider a triangle over here, OAB. Please understand that OB is also the radius of the circle. Okay, OB is also the radius of the circle, and I can say that this is x. The total length of the rectangle is 2x, so that part of OA is x. Now, whatever is given in the question or mentioned in the question can be considered as a constant. Don't say r is a variable. They could have mentioned the radius of the semicircle is 3 centimeters. Instead of saying 3, they said r, that's all. So we consider that given alphabet r as a constant, not as a variable. Now in triangle OAB, OB squared equal to OA squared plus AB squared. OB squared is r squared, OA squared is x squared, and AB squared is y squared. Keep it like this, don't disturb it. Y squared is equal to r squared minus x squared. Not going after the square roots. The second reason I do not like square roots in my expressions for maximization and minimization. First one, I don't like fractions. Second one, I don't like square roots. So I prefer to avoid those kind of values. Now they're trying to find the area of the rectangle. Here, area A is equal to length into breadth. Length is 2x, breadth is y. I have an expression which has two unknown variables, x and y. But I cannot substitute here y because I got y squared, and if I try to substitute y, it will become a square root. And I do not like square roots, so let consider a new variable z as the square of a. Because according to maxima minima, if z is maximum or if a is maximum, its square, a squared, is also maximum. So that kind of an idea is there in the head. So a squared is 2 squared, I can write it directly, 4x squared y squared. Now I can substitute without a square root. Idea, once again, do not try to substitute square roots. Okay, because it's a subjective based case study. So here also we can avoid it, because if it was MCQ based, they could force us to do square roots. Subjective based, they can't force us. So we can write it in any form we want to. So z is equal to 4x squared into r squared minus x squared. 4x squared into r squared. Open the bracket please. 4r squared is a constant multiplied with x squared, and 4x raised to 4. Derivative dz by dx. 4r squared into 2x minus 16x cubed. That is equal to 8r squared x minus 16x cubed. 8r squared x minus 16x cubed. Equated to 0, dz by dx equal to 0 implies 8r squared x minus 16x cube equal to 0. So 16x cube is equal to 8r squared x. So x squared is equal to r squared by 2. X squared is equal to r squared by 2. X is equal to r by root 2. X is equal to r by root 2. Got it? Now what do they want us to find? Find the dimensions of the rectangle so that area is maximum. Show area is maximum. Second derivative, 8r squared into 1. Derivative of x is 1. What's the derivative of 16x cube? Minus 48x squared. Minus 48x squared. Substitute x squared. X squared is r squared by 2 this becomes 24. So 8r squared minus 24r squared, which is negative 16r squared, less than 0. Less than 0 means z is maximum, implies area A is maximum. I already told you I'm substituting the area A squared as z. So if area is maximum, its square is also maximum. Area is maximum. Question not over. It's case study, that's why I'm proving all the parts. Whichever part they want to ask, they will ask. Maybe they will stop with finding the value of x. Maybe they'll ask a part where they'll ask you to prove its maximum. Or maybe they'll ask the part to find the dimensions of the rectangle. I got x. Now what is y squared? R squared minus x squared. R squared minus r squared by 2, which is again r squared by 2. So y is r by root 2. Final answer. Y is r by root 2, x is r by root 2. So tell me the length of the box. So the length of the rectangle, 2x, 2r by root 2, or which can be written as root 2r. 2r by root 2, which can be written as root 2r. And what is the breadth? Breadth is y, which is r by root 2. All of you please go through the question. I think it's very clear. Any doubts you may ask me. The question says to find the dimensions of the rectangle which is inside a semicircle and the radius of the semicircle is r, and the area of the rectangle should be maximum. And this can be made into a case study with different parts. This is how a maxima minima case study is going to be. Expression, find the first derivative to get the critical point, find the second derivative. So the parts could be like expression 1 mark, first derivative 1 mark, second derivative to prove maximum or minimum 2 marks, or maybe dimensions of the figure 1 mark or 2 mark. They could split it like that. Just be prepared with it, that's all. Okay, so I believe it's clear. So I'll do one more question of this type and I will stop with maxima minima and I will go to the next topic. One last question in this. They're cutting a wire of length 28 meters into 2 pieces. Wire may be length of AB, 28 meters is cut into 2 pieces at P. One of the pieces is made into a square. So let me say that AP is made into a square and the second piece is made into a circle. The first piece is made into a square and the second piece is made into a circle. Now they're saying that AP is equal to perimeter of square. AP is equal to perimeter of square. Okay, that is AP is equal to 4a. The dimension of the square is a, means 4a. BP is equal to circumference of circle. Circumference of circle, which is BP is equal to 2 pi r. BP is equal to 2 pi r. AP is equal to 4a, BP is equal to 2 pi r. Now, let me assume that this length is 4x so that I can change everything in terms of x. This length is 28 minus 4x. The reason I'm writing it as 4x is I can write it without a fraction. So AP is 4x and BP is 28 minus 4x. So here, can I say 4x is equal to 4a implies x is equal to a. That is, the side of the square is x itself. And 2 pi r is equal to 28 minus 4x implies r is equal to 28 minus 4x divided by 2 pi. Simplify with 2, r is equal to 14 minus 2x divided by pi. So I have changed the side of the square in terms of x. I have changed the radius of the circle also in terms of x, so that I can get everything in terms of a single variable. Once again, call AP as 4x, BP will be 28 minus 4x. The perimeter of the square is 4a, which will be x equal to a, and the circumference of the circle is 2 pi r, which means r is equal to 14 minus 2x by pi. Read the last part of the question. I need the combined area to be minimum. Area. A squared, area of the square, pi r squared, area of the circle. This combined area should be minimum. I have two unknown variables a and r. I have two unknown variables a and r. So I am going to substitute both of them in terms of x. A is equal to x and r is equal to 14 minus 2x by pi squared. Do you see it's in terms of a single variable x? Do you see it's in terms of a single variable x? Now simplify it a bit further. 14 minus 2x the whole squared by pi. This is pi squared, so you can cancel it and write it as pi. So my expression is ready in terms of a single variable. Differentiate. Derivative of a with respect to x. Derivative of x squared 2x. Pi is a constant, keep it out. What's derivative of 14 minus 2x squared? 2 into 14 minus 2x. And derivative of 14 minus 2x is minus 2. So the derivative completed. dA by dx equal to 2x minus 2 into 2, 4 by pi 14 minus 2x. 2x minus 4 by pi 14 minus 2x. Equate it to 0. Let the first derivative equal to 0. When the first derivative is, when questions of pi is coming by chance, if you get a question of pi, don't be scared. Leave pi undisturbed. Do not substitute a value for it. Okay? First derivative equal to 0. You get 2x is equal to 4 by pi into 14 minus 2x. Take pi to the left side. 2 pi x equal to 4 into 14 minus 2x. You can cancel 2 and 4, get 2 here. Open the bracket now. Pi x equal to 28 minus 4x. Pi x is equal to 20. I'm trying to find the value of x. So collect the x terms on one side. Pi x plus 4x equal to 28. Pi x plus 4x equal to 28. So x into pi plus 4 equal to 28. And x is 28 by pi plus 4. 28 by pi plus 4. I got the critical value for x, 28 by pi plus 4. Now, combined area has to be minimum. Go for the second derivative. See if it is positive. Then you can conclude that combined area is minimum. Going for the second derivative straight away. For a, what's the derivative of 2x? 2 minus 4 by pi, constant. Derivative of 14, 0. Derivative minus 2x, minus 2. And the answer is 2 plus 8 by pi. 2 plus 8 by pi, which is obviously greater than 0. If it's greater than 0, I can conclude that area is minimum. What is the area, my dear students? Area is minimum. Now, one more thing left to find. I have to find the length of the two pieces. I have to find the length of the two pieces. We know the length is 4x and 28 minus 4x. What is the length of the two pieces? AP is equal to 4x and BP is equal to 28 minus 4x. And we do have the value for x, 28 by pi plus 4. Substitute that over here. 28 by pi plus 4. 4 into 28 by pi plus 4. So answer is 112 by pi plus 4. What is the length of the first piece? Don't substitute pi. Don't substitute pi. Leave it like that. 112 by pi plus 4. So what's going to be the BP value? 28 minus 4 into 28 by pi plus 4. Just take LCM. 28 into pi plus 4 minus 112 by pi plus 4. It is 28 pi plus 112 minus 112 by pi plus 4. Cancel these two. Answer 28 pi by pi plus 4. Yes, it involves some difficult calculations, but this part of the answer is for 2 marks. So you can expect a question from this part. So they will not ask you to find all the parts. Maybe they will neglect the second derivative part. They will only ask you to find the critical point and the expression in terms of a single variable. Okay, so 3 parts are expected. Okay, the last part could be the second derivative part or maybe finding the unknown dimensions. Okay, so with this we are winding up AOD chapter. Okay, so we're going to give you a 2 minutes break. Just get to relax, settle down. Before chapter 5, I'm going to start. Few questions in chapter 5 we'll discuss. Not too many, few questions, and then we will wind up today's session. Because we are expecting a 2-mark question to come, maybe also a 3-mark. That's why I want to do a few questions from that also. I have a lot of questions in that, but those questions are for you to practice. I will show those questions in the screen for like few seconds so that you can later come back and practice them. But I will not be doing everything, just few questions will be I'll discussing. Okay, thank you. Go for a 2 minutes break, my dear students.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.
Okay students, so like I said, I want to discuss few questions from continuity and differentiability also. Got it? So if I'll not be taking too much time, maybe like by like 40 minutes I can wind up the session. I want to get few questions from each topic, 2 or 3 maximum from each topic. I'll finish it off by that time. So I have so many questions in this. I'll show it in the screen for like few seconds. Take a photo of it, or like when you come back and watch it, you can have time to get down the question, please. That's why. Okay, the first topic in continuity differentiability is about checking the continuity of a function. 2 mark questions is only expected. 1 mark, yes, but 2 mark is also expected from this topic. How do I find the value of k if the function is continuous at x equal to 0? Function is continuous at x equal to 0 means LHL equal to RHL at x equal to 0. LHL equal to RHL at x equal to 0. LHL means left hand limit. Okay, and also one more condition you can add here. Please add that as well. LHL equal to RHL equal to f of 0. LHL and RHL talks about the value of x less than 0 and greater than 0, but both of them are included in the same part as x not equal to 0. So I will say that limit x tends to 0, 1 minus cos 4x by 8x squared equal to, when x is equal to 0, answer is k. Simple answer. Why did I combine LHL RHL? Because there is no specific separate condition for less than 0 and greater than 0. One limit for 1 minus cos 4x by 8x squared. 1 minus cos x is 2 formula 2 sine squared x by 2 by 8x squared equal to k. 2 and 8, 4. All of you, 1 minus cos a, 2 sine squared a by 2. 1 minus cos a, 2 sine squared a by 2. Now this left hand side clearly looks like sine 2x by 2x whole square. The left hand side clearly looks like sine 2x by 2x the whole squared, sine squared by 4x squared. Okay, and this according to the formula for limits is 1 squared equal to k, that is k is equal to 1. Yes, this expression limit is 1 squared, so k is equal to 1. I believe everybody is clear why the value of k is 1, for which it is continuous. Just applied the formula and got the answer. Straightforward question from limits for 2 marks. Okay, this is another question to show that the function is continuous, again for 2 marks only. To show it's continuous at x equal to 0, the left hand limit of 0 and the right hand limit of 0. Here x is less than 0, here x is greater than 0. Left hand limit, right hand limit. Let's analyze them. And they're saying it's continuous at x equal to 0. You're supposed to find the value of k. So let us take LHL equal to RHL. What is LHL? Limit x tends to 0, square root of 1 plus kx, square root of 1 minus kx by x. And what is RHL? Limit x tends to 0, 2x plus 1 by x minus 2. These two are equal. I'm supposed to find the value of k. Students, whenever you have a square root form, please rationalize. This part, please rationalize. So what happens when you rationalize the numerator? So limit x tends to 0, you multiply with the conjugate of this, so it's going to be root of 1 plus kx multiplied with its conjugate, so a squared minus b squared. Because the conjugate of a minus b is a plus b, so a minus b into a plus b is a squared minus b squared, and the denominator is x into square root of 1 plus kx plus square root of 1 minus kx. Right hand side, put x equal to 0, you will get minus 1 by 2. Now, numerator, simplify it, square root and square, we'll make it 1 plus kx minus 1 minus kx divided by x into square root of 1 plus kx square root of 1 minus kx is minus 1 by 2. Substitute the value of x equal to 0. Substitute the value of x equal to 0. You get, before that, if you put x equal to 0, denominator and numerator both will become 0. You can see that now it's 2kx by x. Limit of x tends to 0, 2kx by x. Inside the bracket, root of 1 plus kx plus root of 1 minus kx. I could not substitute the value of x equal to 0 because numerator was still becoming 0, denominator was also becoming 0. It's a not determined form, so I'm taking the x now away from both numerator and denominator. Now I can substitute x equal to 0. It's 2k by root 1 plus root 1 is minus half. Root 1 plus root 1 is 2 is minus half. So k equals minus half. What's the value of k, all of you? The value of k is minus half. So these kind of simple questions can be asked to find the value of k for 2 marks in your 2 mark section from chapter 5. Please be careful with it. These are 2 questions. Good question. So to prove a function is differentiable, it depends on the weightage of the question. If you're trying to do a question with the 2 marks, you need not try to do the differentiability test and all. You can simply differentiate the function and check if the function is differentiable at all values of x that is given in the question. Okay? If it's a 3 mark question, then you have to definitely take LHD, RHD and prove it. Okay? So again, I'm not going to do all these questions. This is also questions which can be done to find LHL, RHL and then try to find the value of A. It's a 3 mark type question. Don't give much importance for these questions, but practice it. Good questions. More questions are there here. Just showing them on the screen so that you can understand which all questions to practice. These are all very big questions, so just putting this in this so that anybody wants to practice, you can do it. Otherwise, you can just skip it. Now, question 6. This is very good. I'll go one by one. Look at the first question. Discuss the continuity of the following functions. Good question for 2 marks. The function is cos of x squared. Before starting to explain each of the question, I will tell you a few things. F and G are continuous functions. Then, first one, F plus G is continuous. If 2 functions are continuous, their sum is also continuous. This is the algebra of continuous functions. F minus G is also continuous. F plus G is continuous. F minus G is continuous. Third one, F multiplied with G is also continuous. F multiplied with G is also continuous. The fourth one, F divided by G is continuous, but there is one condition along with it, provided G is not 0. The denominator cannot become 0, so provided G is not 0. the last one, if I put a continuous function inside another continuous function, it is continuous. I am putting one continuous function inside another continuous function. Look at cos. Cos is a trigonometric function which is continuous. Here cos is a continuous function, and x squared is a polynomial. X squared is a polynomial which is continuous. X squared is a polynomial which is continuous. That implies continuous function inside another continuous function. Fifth condition is continuous. 2 marks given in your hand. You don't have to do any magic to prove it. 2 marks. Okay? Just explain to them why it's continuous. Okay? We have a function cos which is continuous. We have x squared which is a polynomial function which is continuous. Then one continuous function inside another continuous function. You can just give the explanation. F of g is also continuous. I believe explanation is clear. Now you can just look at it one by one. Cos x, continuous. Modulus is always continuous. Continuous function inside a continuous function. Continuous. Now again, mod x, continuous. Mod x plus 1, continuous. The explanation for this is given in the MCQ discussion, my dear students. You can go and check it. Okay? Mod x minus mod x plus 1. Modulus function, difference between two modulus functions are always continuous. Here again, modulus polynomial added continuous function inside modulus continuous function. Explain it. Here g of x, careful, polynomial is continuous, but greatest integer, you know greatest integer function, it is not continuous, at x which is an integer. If x is an integer, at that point greatest integer becomes non-continuous. Greatest integer becomes non-continuous. So continuous minus non-continuous is discontinuous at integer points. Is discontinuous at integer points. You can look at question 6. Good questions for 2 marks, even for 1 mark also. Okay, explanations are already given in the MCQ discussion. Please go and watch it. But this is a new concept. Please study it. Next one, very important. Discuss the continuity and differentiability of this function. Modulus x minus 2. Everybody knows how to define a modulus function. Positive for x greater than 2, negative for x less than 2. Because x minus 2 becomes 0 at x equal to 2. So for greater than 2 it is positive, less than 2 it is negative. So what is LHL? Limit x tends to 2 for less than 2 minus of x minus 2, which is minus of 2 minus 2, 0. LHL is 0 at 2. RHL, limit x tends to 2, positive of x minus 2, positive of 2 minus 2, which is 0. So I can conclude LHL equal to RHL implies f of x is continuous at x equal to 2. F of x is continuous at x equal to 2. Next one, I want everybody to listen to this methodology I'm going to tell you. I'm analyzing each part of this piecewise function. I can see each of them is a polynomial which is differentiable. Every polynomial is differentiable, so I can confidently say that the derivative of f of x is positive 1 if x is greater than or equal to 2 and negative 1 if x is less than 2. I am straight away taking the derivative of the function because polynomial functions are differentiable. What is LHD, the left hand derivative? For less than 2 it is minus 1. What is RHD, the right hand derivative? It is plus 1. So you can see that LHD is not equal to RHD, implies f of x is not differentiable at x equal to 2. F of x is not differentiable at x equal to 2. So all of you, I check the continuity with the piecewise function. LHL RHL is equal, so it is continuous. But when I took the derivative, why did I go for the derivative straight away? Because I know each of them is a polynomial, so I am allowed to take the derivative. But separately their LHD and RHD are not equal, so it's not differentiable at 2, but greater than 2, yes. Less than 2, yes. But at 2, no, not differentiable. So very easy. This was the doubt that Prapti asked before. Can we directly find the derivative and equate them? And it's possible if it's for a differentiable function. Okay? Very famous question, the differentiability of the greatest integer function. We cannot differentiate a greatest integer function, but they're asking you to test the differentiability of a greatest integer function at integral points. At integral points. So let me assume, let x is equal to 2, which is an integer. I'm assuming it. So between 0 and 3 they say. So I took 2. Okay, fine. So what is the left hand derivative? Left hand derivative definition, I cannot go for derivatives here because I cannot differentiate a greatest integer function. Left hand derivative says that f of 2 minus h minus f of 2 by minus h, because the value of x is 2. So f of 2 minus h, which is limit h tends to 0, the greatest integer of 2 minus h minus the greatest integer of 2 by minus h. My dear students, h is a very small value, very close to 0. So what is, like for example, what could be 2 minus h? It's a very minute subtraction. It could be 1.99 maybe. Subtracting a very small value from 2 makes it 1.99. What's the greatest integer of 1.99? It's 1. So what is the greatest integer of 2 minus h? The greatest integer of 2 minus h can be written as 1. And what's the greatest integer of 2? Which is 2. Right answer, Prapti and Dhruval. So the answer is minus 1 by minus h, which is 1 by h. But the limit says h is 0. 1 by 0 is not defined. So my left hand derivative is not defined. Same process going for RHD, the right hand derivative, the formula limit h tends to 0, f of 2 plus h minus f of 2 by h, which is equal to limit h tends to 0, greatest integer of 2 plus h minus the greatest integer of 2 by h. What is the greatest integer of 2 plus h? Something slightly more than 2. Something slightly more than 2, which could be 2.01 maybe. It's still 2. Yes. So my numerator is 2 minus 2 by h, which is 0 by h. 0 by anything is 0. Don't say h is also 0. H is approaching 0. H is approaching 0. So it could be assumed as a value very close to 0. So 0 by h is 0, and I can conclude LHD is not equal to RHD. LHD is not equal to RHD. So f of x is not differentiable at integer points. F of x is not differentiable at integer points. I believe everybody is clear with continuity and the differentiability part of it. Yes. So now let me go on to the normal derivative forms. Okay, just skipping on. This is one more question. If you want, you can try it. It's 3 marks actually. Not focusing on 3 marks. So 2 marks is my intention for this chapter. Standard question. Find y is equal to cos inverse 1 minus x squared by 1 plus x squared. Find dy by dx. Whenever a question of inverse trigonometry comes, make substitutions which makes it look like a trigonometric formula. I would like to make a substitution here. X is equal to tan theta. Substitutions should be made either as sine theta, cos theta or tan theta, which will give you a trigonometric formula. Put x is equal to tan theta. Right answer. Okay, so y is equal to cos inverse of 1 minus tan squared theta by 1 plus tan squared theta. It's a trigonometric formula for cos 2 theta. So y is equal to cos inverse of cos 2 theta. Cos inverse and cos eliminates themselves. So y is equal to 2 theta. But from the substitution, I know theta is tan inverse x. Theta is tan inverse x. So y is equal to 2 times tan inverse x. So what is dy by dx? The derivative of 2 tan inverse x. 2 by 1 plus x squared. So whenever you have a question of cos inverse for 2 marks, make sure you're substituting sine theta, cos theta or tan theta, which will make it look like a trigonometric identity you learned in 11th standard. Right answer, Shadi. Next, y is equal to sec inverse. I will just tell the substitution, you can try it yourself. Cos theta. If I put cos theta, 2 cos squared theta minus 1 is the formula you know. It's a formula for cos 2 theta. 1 by cos 2 theta is sec 2 theta, cancels off straight away. Answer. Learn it all of you. X is equal to cos theta. This is a very interesting question. Y is equal to sine inverse of 2 raised to x into 2 raised to 1 by 1 plus 2 raised to x squared. I have rearranged the terminologies there. 2 raised to x plus 1 is 2 raised to x into 2 raised to 1, and 4 raised to x is 2 raised to x squared. Here, please put tan theta in place of 2 raised to x. If you put tan theta in 2 raised to x, your answer is going to be sine inverse of 2 tan theta by 1 plus tan squared theta. That's what I say. Make a substitution inside the sine inverse so that it will look like a trigonometric formula. So this is a trigonometric formula for sine 2 theta. Sine 2 theta has a formula 2 tan theta by 1 plus tan square theta. Sine inverse and sine cancels. Y is equal to 2 theta. Substitute that theta as tan inverse 2 raised to x. Tan inverse 2 raised to x. So y is equal to 2 into tan inverse 2 raised to x. So what is the derivative of y? Derivative of tan inverse is 1 by 1 plus x squared. But it's not x, it's 2 raised to x. And so the derivative of 2 raised to x is 2 raised to x into log 2. What is the derivative of a raised to x? A raised to x into log 2. So you can just make some small arrangements and make it look like the question. Do you see that this is 2 raised to x, and that is 2 raised to x plus 1. 2 and 2 raised to x, all of you. 2 and 2 raised to x is 2 raised to x plus 1. Divided by 1 plus 2 raised to x squared is 4 raised to x. So I got it back like the question and log 2. Finished. Okay, so I got it back like the question and log 2. So this is your answer, dy by dx. 2 raised to x plus 1 by 1 plus 4 raised to x log 2. Okay, good answer. Yes, answers coming from good all of you. It's good that this late also you are giving answers. Good. This is a very standard question. Make a substitution for 1 plus sine x. I will just show the substitutions. You can try it at home. Cos x by 2 plus sine x by 2 squared. This is the substitution for 1 plus sine x, and the substitution for 1 minus sine x is cos x by 2 minus sine x by 2 squared. This is how you're going to make the substitutions. The square and square root will cancel. You can simplify it with that, and then divide both numerator and denominator with cos x by 2, which will make it tan 45 plus x. Tan 45 plus x. You can try it at home. It's a very simple question for 3 marks, not for 2, but still practice it. Good question. Okay, this one please. One very quick look at this question. This is the type of question where you see some unwanted numbers inside the bracket. But I would treat those numbers as very much important because they have a particular nature. 5, 12 and 13 are Pythagorean triplets. This is 5, this is, or maybe this is 5, this is 12, this is 13. Pythagorean triplets of a right-angled triangle. So if I call this as an angle alpha, I can say sine alpha is 12 by 13 and cos alpha is 5 by 13. Please learn that for an inverse function, if you see some unwanted numbers, unrelatable numbers inside, they are numbers related to a Pythagorean triplet, and you can use this conversion and also make a substitution for x. I'm going to put x as sine theta. Put x as sine theta. So y is equal to sine inverse of sine theta 5 by 13 cos alpha, root of 1 minus sine squared theta cos theta into sine alpha. Trigonometric formula: sine A cos B plus cos A sine B. Sine A cos B plus cos A sine B. Sine of A plus B. Sine A cos B plus cos A sine B. Sine of A plus B. Cancel each other. Theta plus alpha. This is y. Now what is theta? Theta is sine inverse x. Forget about alpha because alpha is a constant. Alpha is a constant. So what's the derivative of y with respect to x? 1 by root of 1 minus x squared. 1 by root of 1 minus x squared. Okay, so all of you please look at the expression we got here and how we got to this answer. Anybody having doubts, please do ask. Okay, so once again the idea is, if you have some unwanted numbers, change it to a Pythagorean triplet. Now this is based on logarithmic differentiation. Another important question which can come for 3 marks. Okay, logarithmic differentiation. The idea I'm going to give you only in this question. Remaining everything you can do it yourself. Logarithmic differentiation is done only if your power is a variable x or a function of x. Your power is a variable x or a function of x. So I'm going to say y is equal to log x raised to cos x. My idea is to bring the function of x down, so apply log on both sides. So you get log y is equal to log of log x raised to cos x. According to property of log, if there is a power for the term inside log, that power will come as the coefficient. Okay, this will come down as the coefficient. If there is a power for a term inside log, it will come down as a coefficient. So I can say log y is equal to cos x into log of log x. Now I can differentiate. So this type of differentiation is done only if you have a power in terms of x, or maybe it's a complicated expression. So what's the derivative? 1 by y dy by dx. Product rule, u dash into log x plus u into derivative of log x, 1 by log x into 1 by x. So what is dy by dx? Y will go to the other side. This y can be taken to the other side and substituted. Y is taken to the other side and substituted as log x raised to cos x. Remaining terms, minus sin x into log x plus cos x by x log x. No more simplification, nothing. Answer over. So the idea for this type of a question is apply log, bring it down and simplify it. Apply log, bring it down and simplify it. Can you see 2 terms like that? Take it as 2 different questions, u and v. Take it as 2 different questions, u and v. Find du by dx, find dv by dx in the same process in the previous question. This is 3 marks, the other one is 2 marks. Find du by dx, find dv by dx in the same process in the previous question. Therefore, what is dy by dx? It is du by dx. Add both the answers. Add both the answers. What is dy by dx? Du by dx plus dv by dx. Du by dx plus dv by dx. Okay? It's clear? Same idea. Again, u, v. Apply log property. Find the answer from this. The derivative of this is 0 because it's a constant. And from this, because there is y in that, you will get an expression with the dy by dx in it. So from both of them, get dy by dx and then rearrange it over here, get the answer of dy by dx. It's a big question for 3 marks, not expected actually, but still practice it. Like uv, find the derivative u, you will get some expression. Find the derivative v, add them equal to 0, collect all the dy by dx terms, separate it and rearrange it. Separate it and rearrange it. Yes, this is the question I want to do for 2 marks. This is something you have done in regular class, so you can practice it. I want to do this question. It's particularly important for me. So the question is, y log x equal to x minus y. Y log x is equal to x minus y. Actually, it's the same question. But when you see this in the exam, you guys have practiced that, you will think this is completely different question. Actually, if you apply log on both sides, this is what you get. Actually, these are both same questions. So please, you are familiar with this, but when you see this, don't get scared. It's the same thing and the same idea. Collect all the y terms together. Y log x plus y equal to x. So y into 1 plus log x equal to x. So y is equal to x by 1 plus log x. Y is equal to x by 1 plus log x. Now please differentiate. That implies dy by dx is equal to quotient rule yes, u dash is 1 plus log x minus x into 1 by x. So 1 plus log x minus 1 by 1 plus log x squared. Plus 1 minus 1 cancels. Final answer, log x by 1 plus log x squared. Log x by 1 plus log x squared. Now, how did this become this form? I got the answer. We know that log e is 1. So instead of 1, I will put log e. So it is going to be log x by log e plus log x squared. Log a plus log b, log a plus log b, property of logarithm is log ab. So answer, log x by log ex squared. So my dear students, this is something you do repeatedly in class, but if they ask like this, you might think it's very difficult, and you will start differentiating it straight away and you will never reach this answer. Please, this and this is the same. So you have to rearrange it in this particular form if you have to get to this answer comfortably using quotient rule. Okay, so I have discussed the important questions for 2 marks. Yes, there are a few more questions, but I'm not able to do that all of it now. Okay, so please practice the other questions and please make sure you are ready with 3 mark questions of differentiation also. Though it's not mentioned in the sample paper, there are 3 questions of integration in sample paper, and I do expect that one of them is going to be replaced with a 3 mark question of differentiation. So because the total weightage is for calculus, so they can change the pattern. So 3 mark could come back in, and that could be from the second derivative part. The last exercise, second derivative part, please practice it. Okay, so I'll come back tomorrow with one more session, okay, on differential equations and applications of integrals. I want everybody to attend it. The timing will be coming to you in the groups. So please watch it and attend the session. Thank you and good night to all of you.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.